For maximum range, R is equal to R maximum, and that is 2 theta. That is 90 degrees. So theta is obviously 45 degrees. That is, range maximum is calculated by u square over g. For sine 2 theta is 1 because theta is 45. So sine 2 theta means sine 90, and that will be 1. So sine 90 or theta will be 45 degrees. So maximum range is valid for sine 2 theta or theta 45 degrees. When the range is maximum, then maximum height reached is calculated by function h is equal to u square sine square 45 over 2g. We know that sine 45 is 1 over root 2. We take the square of the number, it will become 1 over 4. So u square over 4g. Therefore, the height will be u square over 4g, and therefore the maximum height reached for maximum range is 1/4 of the range maximum. So h is equal to r maximum over 4. Now for the height to be maximum, h is u square sine square theta over 2g. That will be maximum. That is sine square theta is equal to 1, or theta is 90 degrees, because sine 90 will always be 1, and if we take the square of 1, it will remain 1. So that h maximum is u square over 2g when projected vertically, that is at theta 90 degrees. In this case, the range r will be u square sine twice of 90 degrees divided by g. Then it is written as u square over g, and 2 into 90 will be 180. So sine 180 degrees, that is 0. So range will become 0. For the vertical projection, that is maximum height, it is u square over 2g. And for oblique projection with the same velocity r, maximum, that is u square over g. That is, we are finding it is half of this value. H maximum is r maximum over 2. If a person can throw a projectile to the maximum distance, so that is theta 45 degrees, range r maximum will be u square over g. The maximum height to which he can throw the projectile when theta is 90 is taken as half of the maximum range. So h maximum is equal to r maximum over 2. At the highest point, potential energy will be maximum, and the kinetic energy will be converted into potential energy. And this potential energy at the highest point is mgh. Now this is equal to mg, and for h we have computed the value, that is u square sine square theta over 2g, or potential energy at the highest point is half mu square sine square theta. U sine theta is basically the vertical component. We have taken the square of the number. While kinetic energy will be minimum but not 0 at the highest point, that is, the whole of the kinetic energy will be transformed into potential energy in accordance with the law of conservation of energy. So kinetic energy at the highest point is half mvh square, and this is equal to half m u cos theta square, where u cos theta is the horizontal component, and this is equal to half mu square cos square theta. So potential energy at the maximum height plus the kinetic energy at the maximum height, that is sum of the total energies, will be, we have computed the values, that is half mu square sine square theta plus half mu square cos square theta, and that is equal to half mu square. This is equal to the total mechanical energy, that is sum of the potential and the kinetic energy. So in projectile motion, the mechanical energy is conserved. The ratio of the two energies is calculated by putting their values, and that is come to be 10 square theta. So if theta is 45 degrees, 10 square theta will be 1, because 10 45 is 1, and 1 square will remain 1. Potential energy is equal to kinetic energy equal to half of mechanical energy at the highest point. If body is projected at angle of 45 degrees with horizontal, then at the highest point, half of its mechanical energy is kinetic and the remaining half will be potential. In case of projectile motion, if range is r is n times the maximum height, then r will be nh. Then we can compute the values. That is u square sine 2 theta over g is equal to n times of u square sine square theta over 2g. Therefore, by calculations, 2 cos theta is n sine theta over 2, or this can be converted to tan theta. So tan theta is 4 over n, or theta can be calculated by inverse function, that is theta is tan inverse 4 over n. Apparent weight of the body in projectile motion is 0 as it is freely falling body.